Okay, so good evening, one and all. This is fifth day of our FDP. We have till now covered the meaning of terms used in research, then parametric, non-parametric, regression, and yesterday we were talking about exploratory factor analysis. So first of all, I would like to ask you if you have any doubt, you can discuss. By the time others join, if you have any kind of doubt, you ask from the content of day 1, 2, 3, and 4. Do you have any kind of doubt? Hello, Dr. Karuna.
Sir, hello, sir.
Ji.
Yeah, yesterday I was not able to connect due to some reason. So yesterday का थोड़ा एक दो मिनट कुछ review हो सकता है क्या? If possible.
Okay. We will try. We will try. Definitely, we will try. We will give a quick recap.
Actually, I met with an accident on Friday, sir. So I was
Oh,
not well. But Saturday I tried to join. Sunday it was totally not well. So
okay.
sorry for that, sir.
No issue. I will try to recap whatever we have covered yesterday, and today we will take it forward. So we will revise yesterday's content. Anybody else who has any kind of doubt or any question or want me to discuss something? No? Okay. So let's start. Yesterday we were talking about exploratory factor analysis. So I covered the types of scale, reflective as well as formative scale. For exploratory factor analysis, formative scale is not working. So we need reflective scale for EFT. Reflective scale is the scale in which we ask the same thing from the respondents again and again, but in a different manner. So all the similar kind of statements are grouped under one construct factor that is known as factor, and this is done by the software SPSS known as factor analysis. So once again, I'm sharing the PPT and I will try to recap quickly whatever we have done yesterday. After the session, anybody exercised it? Anybody who have done exercise after session? No? Okay, no issue. So yesterday we discussed about, exploratory factor analysis. We told you what is exploratory factor analysis. It is basically dimension reduction when we take the response from the respondents on many statements. So at EFA will club the highly correlated statements in a single factor. So that factor will work as variable for us in future. So scale, types of scale, reflective and formative. Reflective scale is the scale in which we ask the same thing from the respondent in different ways, but same thing. I have given you the example. Also, I help people by providing money. People ask me for money. My relatives and friends think that I'm a good uh, source of money. So we can say that this factor talks about the economic help. Okay, economic help. So if answer to the one statement is positive, then answer to the rest of the statements must also be positive. And if we have similar kind of answer, there must be high collinearity, high correlation, not collinearity, high correlation. So I club all of the statements having high correlation into one group and I will give the name. So in case of formative scale, I ask different things with the help of statements. Here I can directly apply regression. I like to buy online. I prefer to pay in cash. So I use all of them as independent variable, and I can directly run regression. But in case of reflective scale, I can't use them as independent variable because they have high degree of correlation, and in regression they will create a problem known as multicollinearity. So the solution for multicollinearity is factor analysis. So problems of reflective scale, again, multicollinearity that is checked by Cronbach alpha. Cronbach alpha, if high Cronbach alpha is there, then it creates multicollinearity. Then we go to factor analysis, and it is dimension reduction technique. In this, uh, you know, the condition to use EFA is if there is no literature review available. If literature review is available, and I think that I should not go with that literature, I should create my own things. Then also we can go for EFA, exploratory factor analysis. We are exploring something new. If you have this questionnaire developed by somebody else and you want to check it to your own set of population, then it will not be EFA, it will be CFA. So today we will take the session towards CFA also. So EFA, then we have done. I'm just quick recapping whatever we have covered yesterday. Assumptions, data must be metric, either on interval or ratio scale. Multicollinearity must be there. We will check with the Bartlett test of sphericity. Adequacy of sampling, KMO. There are certain limitations. Yesterday we discussed about the correlation is the basic requirement for factor analysis, reliability of measurement of scale. Yesterday we have not covered this, today we will do. And larger sample size must be there. We will check it with the help of KMO. Yesterday we have discussed about a lot about KMO. Sample should be representative of population. So this is the internal consistency also, unidimensionality, unidirectionality, same scale for statements, all these things. I have written all the steps for data cleaning and for you know checking the file before going for ESA. I would like to discuss something today about data cleaning. Yesterday at the end we have discussed about data cleaning. So some problems we may face in this reflective scale data, but some problems may not be there at all. For example, if I talk about outlier, is it possible in scale data that I have an outlier? What do you think? Is there any probability of outlier in scale data? Scale means when I call it scale means 5-point scale, 7-point scale, 9-point scale. Is it possible to have outlier? Hello? No. So there is no possibility of outlier because respondent will answer out of the options provided by you, either 1 to 5 or 1 to 7 or 1 to 9. Whatever options you have provided to the respondent, he or she will take out of them only. So there will be no outlier. Yes. Possibility of typing error is there. At the time of entering my data, in place of 1, I enter 11. In place of 2, I enter 2 or 20, 22 or 21, whatever. So that is possible. So yesterday I told you how to check for that. We will go for descriptive statistics, then frequency. We will see if there is typing error, we have value beyond the options, then it will be shown just above the total. You will get it, you will find it, you will remove it. Then again you will apply data cleaning part. Categorical, one more option we can have, check for categorical merging. Likert scale, we don't have any kind of issue in this. You must understand what is categorical merging. In case of categorical data, let's say income categories, education categories. I have given the options um, illiterate, 8th pass, 10th pass, 12th pass, and graduate, postgraduate, PhD, Julie. I have collected the data. I find only one respondent as delete. What should I do? I should take it as separate category because I don't have sufficient responses. So this is my option, whether I should merge it with the nearest or should not merge. But it is always advisable to merge that category. So we will merge the category which has very less responses to the nearest category. So delete the respondent who has done delete. I think if one response is there, so I will go to merge it with the nearest one, that is PhD. Like that, this is, but there is no problem in scale data, Likert scale data. Check for outlier, there is no possibility of outlier. Yes, in ratio data, it is possible. Check for unengaged data. Yesterday, I explained to you how to check for unengaged data. We will go to Excel. We will calculate standard deviation. If the standard deviation is 0, then it means the respondent had answered at the same level to all the statements. Means 3 means 3, 3, 3, 3 to all statements. 5 means 5, 5, 5, 5 to all statements. Those who have missed, they can go and watch yesterday's recording. Then, if you have any kind of problem, you can write again. There is no issue. Now, today we will start with the help of reliability of scale. What does it mean by reliability of scale? Can anybody tell me how to check? That is a different issue. But what is the meaning of reliability? Reliability of scale. Hello? Because understanding of term is very important. Running test is not so important.
So I think if the scale is giving same results under different conditions,
Very good.
So
One point is
that is a reliable skill.
very good. One point when I ask the respondent again and again, same responses I get from the different set of respondents. So it means my scale is reliable. What else? What else? What else? Second point is that what I need to convey to respondents, are they understanding the same thing or some different thing? Suppose yesterday we have seen there was one negative statement. Are respondents reading the statement as negative, or they are simply reading it as positive and answering accordingly? So if I have framed any negative statement and I'm getting answers as per positive statement, then I need to revise the statements, because what I need to say, the respondents are not understanding. So what if uh, after having negative statement, I'm receiving the responses as the statement is positive? So I have to check. So reliability consists of these two things, whether the respondents are understanding what I need to say, or I am getting the same, not same, almost same responses in different conditions. So this is reliability. How to check reliability? So we will see. I'm opening the file, same file. You also have the file. Anybody who does not have file? Okay, you don't have file. Is your email ID correct? Okay. You both write your email ID in chat box quickly. Okay, you have. Okay, okay, thank you. If you have done it.
Excuse me, whether the file was shared yesterday or today?
Yesterday. The same file we will work.
Uh-huh.
Okay. Hani Kalwa, you don't have file?
Yes, sir.
You don't have file. You need file.
Yes, sir. I don't have. I need it.
You don't have.
I don't have, sir.
Okay. Just wait. Then we drop the file here.
Just to confirm, this was a banking during
Yes, same file. Banking during lockdown. Banking during lockdown. It is same file. So I'm forwarding the file to you. Please see. You must have received the file. Okay. So this was my file. Try to understand the data once again. This is variable view. I have 13 statements related to banking during lockdown. I have written certain statements. One statement was negative. That statement number 6. The information provided on website is not up to date. I have 4 categorical variables: qualification, age, gender, income. So this is my data file, and I have data on 7-point scale. I can see from here 1 to 7. 1 means disagree completely. 7 means agree completely. So what we did yesterday, we run factor analysis. But today we are talking about the reliability of the scale. So how should we check reliability of scale or reliability of construct? What should we do? Yes, please tell me. Reliability of construct or reliability of scale?
Sir, both.
Both. Very good. So first we will check reliability of scale, means all the statements, and after making the factors or constructs, we will check the reliability of each construct or each factor. Fine. So first of all, we will go for reliability. So from where we can go for reliability? Go to analyze, then scale reliability analysis. I'm repeating, go to analyze, scale, then reliability analysis. So I will check the reliability of scale. I will not transfer the data of demographic variable. So by default, alpha, yesterday what we discussed about alpha, do you remember? So my answer is number of statements are 30, Cronbach alpha is 0.853. Whatever is the Cronbach alpha above 0.7 is deemed to be good enough. Sometimes we also consider the Cronbach alpha more than 0.6 also. But what does mean by Cronbach alpha? What Cronbach alpha tells me? Yesterday I told you. Does anybody remember? Hello? When we check relationship, correlation between two statements, this is represented by R. Yes or no? Correlation is represented by R. When I check correlation among more than two variables, it becomes alpha. So the value of alpha is there. So alpha will tell me whether they are correlated or not. So this is the reliability of scale, and as we can see, the answer to the reliability is 0.853. Then this is good enough. What should I do? I should run factor analysis once again. Can anybody tell me the steps? Do you remember? We are repeating the steps. Anybody? Don't remember?
Analyze
Okay,
and
very good.
dimension reduction.
Analyze, dimension reduction, then factor. Okay.
Correct.
But yesterday you have seen that one variable was negative. Okay. And I have not saved the new variable in the file. So what should I do before running the analysis? I am creating one new variable. So transform compute variable. It was S6, so new S6 I will create is equal to 8 minus S6. Okay. So what happened into data file? I have one new variable that is S6, new S6. So I will not use S6, I will use new S6 because values has been transferred. So analyze, dimension reduction, factor. I will transfer all 13 variables. No, S6 will not be used. New S6 will be used. Okay, description. I need initial solution. I need anti-image. I need KMO. Extractions, principal component analysis PCA based on eigenvalue, one or more than one. Rotation, Varimax, 250. Continue. Scores.
Sir, please
Yeah,
slow
please.
down. It's very.
Go down. Okay. So should I repeat again? Go to descriptives.
Please.
I need anti-image and KMO. Okay. Anti-image, yesterday I have explained to you. Anti-image tells us the KMO of individual statement, while KMO tells us the sampling accuracy of complete set of statements. Continue. Extractions, I need PCA. Why PCA? We have all other methods also. Why I need PCA? Because PCA makes the factors which are totally uncorrelated. PCA makes the factors which are totally uncorrelated. That's why I am applying PCA. Based on eigenvalue, it is asking how many factors should I make. So I told the software that based on eigenvalue, the factor having more than one eigenvalue, make it a factor, otherwise leave it. Continue. Rotation. Yesterday we have discussed about rotation, why we need rotation. If I do not go for rotation, what happens? First factor will be most important, and the difference between first and second factor, second and third and fourth will be very high. After the rotation, still first factor will remain most important, but the difference between first and second, second and third, third and fourth and so on will be very less. So we will tell you after analyzing this. Continue. Yesterday I explained this. Scores. Now I do not want to save the scores, so I will cancel it. Options. I need sorted by size, suppress less than 0.4. Yesterday we have seen this. This will calculate all the values, but it will not show me the factor loadings less than 0.4. I will click OK. Results are here. I can see the results. First, I will check the KMO and Bartlett test. So, what are the meaning? What is the meaning of this KMO? KMO is 0.870. It tells me that my sample is adequate to go with the analysis. More than 0.6, it's deemed to be fit. Bartlett test of sphericity, I will see the significance value. The null hypothesis of Bartlett test of sphericity is there is no correlation among the statements, and that should be rejected. So in my case, it is rejected because significance value is 0.000. It means there is a correlation among the statements, which is prerequisite for exploratory factor analysis. So first of all, I will see this KMO and Bartu's test. I have seen this, and this is showing me that 0.870 and 0.000. It is good enough. Now come to anti-image. I told you we will not go for variance. We will see. Yes, please.
I did not get KMO test. I don't know why. What mistake I did.
You have you checked it at the time of running the here?
Yes, sir, I done that.
Okay. So can you share your screen? I'm stopping.
Just,
Hello.
yes, sir. Yes, sir.
Okay. Please share and be quick. Yes. You have any questions, Srikanth? Srikanth, do you have any question? Please share.
Yeah. Can you see?
No, not visible. Yeah, it's coming. Okay. 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 Run the factor analysis again. Run the factor analysis again.
Yeah. Acha, so you can't see. Huh? I have to show all windows.
No. Yeah, on that window also you can run. On output window also you can run. Don't worry.
Uh-huh. Okay, no, I'm sharing.
You can run test on output window or
Okay.
data file. No problem.
Can you see now?
Okay. Can you see now? Yeah, please.
So this was my.
Okay. Okay. Go to descriptive.
Yeah.
KMO. Okay. Anti-image. Check anti-image. Anti-image. Under descriptive. Anti-image. Well, I think you have taken one categorical variable in your continue. See the variables. I think you have taken education as in the right hand side. You have taken education
Qualification.
Yeah. You okay? Yes. Now click OK.
Rotation is correct.
Very much. Yes. Correct.
Okay.
Continue.
Course.
Scores. You can save or you cannot save. I will save later on.
Okay. Option.
Option. Okay. Fine. Sort by size.
Sort.
You check. Yeah. Sort by size.
Okay.
Okay. Click OK.
So
Go down. Go down. Down. Because you have run 3 times.
no, this is the last.
All of this is last one. Go up. Just why this is happening? Again, go to the file. Again, go to the analyze. On this file itself, go analyze. Dimension reduction factor. Okay. How many variables you have transferred? No requirement.
I've added all. New 6. Okay, new 6 I have not. Is it so?
Have you created new 6
Yes.
after transforming?
Yeah. Just a minute. New 6 is here.
Okay, 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 okay.
So, but any other change in data variable do you need to do?
Just scroll to the right hand side. New 6 you have not given, just 1 minute. New 6 you have not given the
Label, no?
values. Copy and paste values from anyone. Values, right side.
Okay,
Values,
okay.
go above. Okay, copy it. Control C, Control V, and go to measure. Measure. These are scale, not ordinal data. Scale. Change all of them.
It's all. Can I change one go?
I think you can't.
No. Okay, done. I will do that. Maybe that is a mistake.
I think after this you must get it.
I'm sorry, I'm taking other.
Go quickly. But others are not asking questions. They must ask.
I think. Yeah, that's all.
So leave it. The qualification is not a scale. Qualification is not a scale, but we are not going with the.
This one. Here, I need to copy and paste.
No need to get.
Only,
Or you can write only whatever you want. There is no requirement for this.
No problem. So then, should I do again?
Yes. Run.
Okay. So just
Reset. Reset. Okay. Now I transfer. Leave new 6. You transfer these only. You transfer. Only the difference will be the negative value.
new 6. This side.
No. The
New 6 I should not.
you should not. Otherwise, you have to drop
No,
one variable.
I will remove 1 6.
Yeah, remove.
1 2. This one is.
No. This one was not there. 6 was. Just wait. S6 is the information provided on the website.
Okay.
Information provided on the website. Yeah, the same. I think you are doing right. Okay. Now go to descriptive. Once again, check KMO value, anti-age, continue, extraction. Okay, continue. Continue.
You have to put 250 here, right?
No, not in this rotation.
Okay.
Rotation.
Okay.
Very max. Check very max. Now to. Okay, continue. Expose, leave it. Cancel. Options. Sorted and suppress. 0.4. Okay, continue. Okay.
Yes.
Now you got it?
Yeah.
Okay. Please stop sharing your screen. Okay. So I have the results. This anti-image, yesterday I told you, we will see the anti-image correlation and we will see diagonal values. If any diagonal value is less than 0.6, we must drop that particular variable. So we have S7, adoption of online banking reduces the use of natural resources. This statement has value less than 0.46, so we will drop this statement. Again, we have another parameter that is communalities. We have to see whether any statement has community less than 0.5. So again, the same statement has communality less than 0.5. We should drop it. Then go to total variance explained. This is unrotated and this is rotated. So yesterday, whatever I told you, please remember the first variable is most important here also and after rotation also. But the difference between first, second, third has been reduced here. So percentage of variance explained total will remain same, but explained by each factor will become nearby. So it has made three factors based on eigenvalue, and my eigenvalue is for first factor is 5.940, for second 2.129, for third 1.266. So I have three factors. I will not see this component matrix because this is unrotated. I will see the rotated component matrix. So because I have transformed the variable, so I have the positive value mu6. Otherwise, this must have come as minus value, negative value. This seventh S7 does not have any factor loading either in factor 1, 2, 3. So I need to drop it. So what I will do, I will drop this S7 and I will run factor analysis again and I will save the scores. So go to analyze, dimension reduction, or one more thing, my SPSS remembers my previous commands. Okay, so this is the option where I can click and I can get my previous 10 commands. 2, 4, 6, 8, 10, 12 commands I can remember. Means software remembers. So I will directly go to factor analysis and I need to drop S7. Okay, and other things will remain same. Extraction, okay, rotation, varimax, continue, scores. Now I will save my scores of variables, and the best method is Anderson Rubin, ND field की book में था. ND field told is this: continue, options, this, continue. Okay, I have my results, so I will suppress the previous results, and I have these results with me. So KMO value has increased from 0.870 to 0.871 because I have dropped one variable, one statement. So number of statements are less for the same set of respondents. So I have made it. So this is the, factor analysis. I have done this for my factor. So what I need to do, I need to check these factors. So if you have paper and pen, you can note down which statement goes to which factor. Okay. So the process of transaction is fast. I think just okay. So we can see from here the process of transaction is fast. So I need to see process of transaction is fast means S8. So I'm noting down S8. Okay. Second one is new 6 is there. Content provided on website is reliable. The content provided S10. Then bank website does not feed. Bank website does not feed S5. Then wide range of products, wide range S9. These are under one factor. Factor 2, I think use of online banking S3. Then banks give you proper S4. My bank follows online S2. And I think that COVID-19 as well.
So can you please,
Yes, please.
why we are noting down?
I will tell you because factor wise we will check the reliability also. Factor wise, okay. And for the last one, I have access to all this S12, S11 of online banking, S11 and S13. Okay, so what happens now in my data file? Is it visible? Data file. I have seen new variables, name as factor 1, factor 2, factor 3, and data under the data I have 3 factor scores for factor 1, factor 2, and factor 3. It means what this factor analysis has done for me. In factor 1, there are 5 statements. The all 5 statements are clubbed, and SPSS, with the help of factor analysis, has given me one value out of those 5 statements. In case of factor 2, SPSS has given me single value out of 4 statements in the factor 2. In the same case of factor 3, SPSS has given me the value out of 3 statements, one value. So out of 13 statements, I have 3 factors now only. I can use these factors. From where to use, how to use, I will discuss today. So first of all, I should check the reliability of particular factor. So go to analyze.
Sorry,
Yes,
sorry.
please.
How
No,
we
no,
got
no.
data, sir? Where
How we got
this data set, new one?
scores, scores, factor score. Are you asking about factor score?
Yeah, yes, new one. You
So,
column merging
yeah,
together.
at the time of running factor analysis, you check the box that is score and opt for Anderson-Reuben method. Anderson-Reuben method. I'm just telling you where did I get. Go to factor analysis and see the score. Score. Okay. Save as variable. Anderson-Reuben method. Okay. If you take this and run the factor analysis, you will get them in your data sheet. Okay. So what I need to do, I should check the reliability of the particular factor. So I will go to analyze, scale, reliability. So in my first factor, tell me the number of statement. Which statement was in factor 1? Which statement? I have written S8. Okay. S5, S9, S10, and new S6. Okay. So I will check the reliability of this factor, this construct. So see, these are the answers. Are these visible? Hello? Are these visible? Anybody can respond?
Yes, sir.
Okay. So Cronbach alpha is 0.875 and number of items are 5. So I can say this particular factor is also reliable. Same way, I will go to the second factor, the statements of factor 2 was as 1, 2, 3, 4. 1, 2, 3, 4. Okay, I will click OK alpha. Cronbach alpha is 0.914. Number of statements, number of items are 4. I will go to the third factor and number of statements to the factor 3 was 11, 12, 13. Okay, you can see the Cronbach alpha is 0.927, number of items 3. So I have checked the reliability of my scale as well as construct. Now tell me, is it clear or anything else you want to discuss? No. Or should I move ahead? Hello, is it fine? Any question till now?
Yes, sir.
Okay. Now, I want to check whether my factors created by SPSS are correlated or uncorrelated. Am I clear? I want to check whether the factors created by SPSS by factor analysis are correlated or uncorrelated. What kind of factors I need? Uncorrelated factors. So what will I do? I will go analyze descriptive. Um, okay. Compare means general reach. Just a minute. Descriptive frequencies, and I will transfer my factors here, and statistics what I need standard deviation and variance mean, I think. Okay, continue. Okay, the frequencies I have calculated the mistake. Descriptive, yes. Factor 1, 2, 3, options. Continue. Okay. Now, see, is this table visible to you? Can everyone see this?
Yes, sir.
So, what is visible? The standard deviation is 1 and mean is 0. Standard deviation is 1 and mean is 0. Is it visible? I think by mistake I have done. I'm sharing again. Okay. One more thing I want to calculate here. Correlation among these three. Okay. Now, what you are able to see here, the correlation is 0. Factor 1, 2, 3. Correlation is 0. The correlation of factor 1 with factor 2 and 3 is 0. Factor 2 with factor 1 and 3 is 0. Factor 3 with factor 1 and 2 is 0. Is it clear? So I have totally uncorrelated factors.
I don't know.
Hello?
That's not clear. Can you just again show the correlation option, how you do it?
Go to analyze, correlate, bivariate, and
I believe there is no two variable, no? Only three variable, more than three, right?
yes, 3 variables. So you can check one with 2 and 2 with 3 and 1 and 1 with, or you can go for multivariate also. We have one option again in analyze descriptive, exclude statistics descriptive. Mm, range, experience, purposes, some. Ultimately, you have to see the correlation among them, and that is 0. So you have the correlation matrix here, and they have correlation 0.000 among all of them. So standard deviation 1, we have calculated standard deviation here. Standard deviation is 1 and mean is 0. It means they are totally uncorrelated factors. Now the question arises, what is the use and what is the purpose of calculating these factors? So now I want to come to my PPT and I want to write something here. See, this is the analysis of results. Okay. Okay, so I'm writing here something. Please see carefully. The point number 1. If your objective, I'm talking about objectives. If your objective is to determine the factors of, okay, whatever is your variable, then your EFA, and after EFA, you have factors, your job done. Tell me, any doubt, any confusion? What was your objective? Your objective was to find out, to determine, whatever terminology you use, the factors of whatever, satisfaction, factors of buying behavior, factors of whatever. And you found some factors with the help of EFA, your factors, your job done. Clear? Clear or any doubt? Please tell me.
Clear, sir.
Yes, sir. Okay. Now, if your objective is to determine the level of, okay, let's say satisfaction, let's say whatever you is your objective, then what we need to do, these factor score will not work here. This factor score will not work here. Then what will work? What will work? Then we will go. Do we have? This was the question raised by. Who raised this question? Mean score. How to calculate mean score? Objective part. Somebody was having objective. This objective. Just a minute. Let's see here. Sapna madam. Sapna madam. Sapna madam.
Yes, sir.
So I think this was your objective level of something, and you asked me how to calculate mean or what I need to do. Okay. So
Yes,
what
yes.
I will do,
The level
what
of training.
yeah. So for that purpose, what will I do? I will make the factors, but I will not use the factor store. I will go to transform and compute variable. I will create new variables. Like in my case, I have three factors, so I give the name F1, factor 1. Exact name will be given by the researcher, whatever is the objective. In my first factor, I have the, so what I will calculate mean, or mean of what? My statements. So I have statement number 5, 6, 8, 9, 10. So this is 5. I will double click here, comma 6. In place of 6, I will take new 6, comma 7. I need not to take, then 8, comma, then 9, comma 10. Okay, close. Okay. Again, I will go to transform, compute variable. I will calculate F2, factor 2, and I will write the variable statements of factor 2, 1, 2, 3, 4, 5. So 1, comma 2, comma 3, comma 4. Okay. I will again go to transform, compute variable, factor 3, and I will write here 11, 12, 13. Okay. So what happened to my data sheet? I need to see. I have the scores of factor 1, 2, 3. These are the mean scores of factor 1, factor 2, factor 3. So Sapna madam, you will use this, okay, and you will see whether the number of respondents are towards your positive side or negative side. Now see the variable. 1 means disagree, 7 means agree. So see the number of responses means roughly see responses are towards 1. Towards 1 means less than 4 because 4 was neutral, and or the numbers are, or mean score is above 4. If it is above 4, you can say they are satisfied. If it is less than 4, you can say they are not satisfied. So level of anything, if you want to calculate, you need to use this kind of score. So either objectives, objective 1, objective 2 clear. Hello. Any question
Yes,
now?
sir.
Any question till now?
So
No.
this way we can see the sufficiency level or satisfaction level of any of the factor, either three, all the three,
Yes.
or even single factor also.
Separately, you have to see separate, because you must have
Yes.
three different objectives, na? You must have three different
Mm-hmm.
objectives. For factor 1 different objective,
Yes.
for factor 2 different, factor 3 different. It's clear? Okay. Now see what can be the
Yes.
third objective in EFA. What can be the third objective? Third objective is to check the factor. Now you will write the name of factor, okay? Other satisfaction, motivation, whatever you have checked. Okay, differs on the basis of category. Of category means categorical variable. If I write categorical variable, what does it mean? Categorical variable. If I write specifically to check the satisfaction level, satisfaction to check whether satisfaction differs on the basis of gender. Okay. In this case, you will use the factor score calculated by EFA, exploratory factor analysis, and you will run t-test or ANOVA based on your objective. Objective is category. If you have two categories in gender, you will run t-test, independent sample t-test, and if you have more than two categories, then you will run ANOVA. So let's check. We have factor score calculated by EFA. Okay, this is the factor score. So we have three factors. So what I need to do, if I am checking for gender, I need to check for gender what options I have given here. So I have given gender. Okay, one for male, two for female. So analyze, compare means, independent sample t-test. I will transfer all the factor scores here. Dependent grouping variable is my gender. I will transfer gender. Define group 1 and 2. Click OK. Then OK. What you see here? First of all, you have to see the leavenage statistics. What was the leavenage null hypothesis? Can anybody tell me? Do you remember? Tell me. Hello? No? The null hypothesis for leavenage test was homogeneity of variance assumed. Okay. So equal variance is assumed and significance value is 0.745. So I cannot reject this. It means there is homogeneity of variance between two sets of data. Two sets means data from respondents like male and data from respondents female. If this happens, I will see the significance value. Otherwise, I will not see the significance value. If the leavenage test rejects the null hypothesis, then I will not see the significance value. If this accepts the null hypothesis, I will see the value. So I can see in case of factor 1, there is no significant difference in the responses of male participants and female participants. While in case of factor 2 and factor 3, there is a significant difference between the responses of male and female participants. So I can say that yes, the responses differ on the basis of gender in case of factor 2 and factor 3. Am I clear? Am I clear? Sapna madam?
Sir, can you repeat once more, please?
Please ask. Okay. So till now, I have done the T analysis. I have applied T test on all three factors on the basis of gender. These three factor scores, which were computed by the software, I have taken these scores because out of 13 statements, I have made 3 factors. I have given certain name to 3 factors, let's say satisfaction, motivation, leadership. Okay. So factor 1 is for satisfaction, second one motivation, third one for leadership. So if I have collected the data from respondents and On the basis of gender, I am checking. First of all, I will check Lebanese test for equality of variance. Null hypothesis is equality of variance assume, equal variance assume. I can see that I cannot reject my null hypothesis in any of case. If I cannot reject null hypothesis, it means I can accept null hypothesis, then only I will see the significance value. If the significance value of Lebanese test is less than 0.5, not sorry 0.05, then I will say that there is no equality of variance. So I will not see the. It is suggested not to see or not to apply t-test. So in my case, equality of variance assume. I can go ahead. Yes, please.
GC of variance.
Sir, can you speak little louder? Your voice is not. Satyennath Pandey, sir, you are speaking to us or at home? Pandey, sir. Okay. So, if equality of variance is assumed, then we will see significance level. In case of factor 1, let's see satisfaction. There is no significant difference because the p-value or significance value is more than 0.05. But in case of second and third factor, say motivation and leadership, I can say there is a significant difference between the responses of male and female. Okay, it's clear. Is it clear?
Yes.
In the same way, if I have,
Sir,
yeah, please.
so do we
Please,
also run multiple comparisons in the same?
Like, what do you mean by multiple comparisons?
We run the post hoc test in this case, sir. Sometimes.
I could not hear you. Please repeat.
Sir, I mean that sometimes we also run the post hoc test.
No, post hoc is required in ANOVA. So if you have more than 2 categories, then run ANOVA. If you have homogeneity of variance, if you don't have homogeneity of variance, you can go for Welch test. And in case of ANOVA, the post hoc is Turkish. In case of Welch, means homogeneity of variance is not there, you will run Welch. Post hoc is game solver test. In PPT, I have given you the things. I think when we were running ANOVA, explained this. Give me 1 second. See this. See, Lebanese test will tell us homogeneity of variance is there. Then ANOVA. If ANOVA suggests us that we have some difference in the responses, then post hoc technique. Okay. In case of no homogeneity of variance, then we will go for non-parametric, that Welch test. If Welch suggests the significance, then gains over. Okay. So for more than 2 categories, go for ANOVA. It will tell you. So in the same data, if I run the statistics for one categorical variable having more than 2 categories, then I need to run ANOVA. Okay. Clear?
Okay.
So I can use the factor score for the t-test and for ANOVA. I think it's clear. In the same data set, if I want to run ANOVA, I need to see the category. Category having more than 2. Age has many categories. I can run ANOVA here. And income has also, age group also has many categories. I can run ANOVA. Income has 5 categories. 1, 2, 3, 4, 5, 6, 6 categories. So on income, I'm running ANOVA. We go to analyze. Again, compare means one way ANOVA. And I'm running these on factor scores. Please remember, not statements. So this is income and okay, post stock the keys in case of ANOVA, then okay. So I have the results ANOVA table here. I have not for one way ANOVA, the confidence. Homogeneity of variance. I have to check homogeneity of variance. So I will run it again. Yes. So first of all, I will see the homogeneity of variance. This is the test for homogeneity of variance. I can see homogeneity of variance is assumed in case of factor 1. For factor 2, it is not assumed. No, sorry, it is also assumed. For factor 3, it is not assumed. So for factor 3, I cannot run, ANOVA. I need to run Welch test, then Games oval. But for factor 1 and 2, I can run ANOVA, then post op. The keys post op. Okay. Is it clear? So I can see in factor 1, there is no significant difference. In factor 2, I can see here also there is no significant difference. This category is somehow different, over 1 lakh or over dollars. This is different, but other categories are not different. In the case of factor 3, no categories. So any question till now? All of them are in one subset. In case of factor 2 also. So there is no significant difference on the basis of income. Yes. Any question or should I move ahead? Please tell me. I have content to cover.
Sir, move ahead. Move ahead, sir. Move ahead.
Very good. So you may have fourth objective also. You may have a fourth objective also to predict a model for dependent variable on the basis of factors calculated in EFA. So in this case, all independent factors you have calculated, dependent variable you must have separately, because there is no problem of multicollinearity. So you can take all these factors as independent variable and you can run regression analysis. You can build a model on the basis of these. Done. Okay. So now let's move ahead. So day 5, the agenda for day 5 is AMOS. How many of you are aware with software AMOS? The full name of AMOS is Analysis of Movement Structure. Is anybody aware? Tell me. Nobody? Okay. So first we will discuss about the introduction of AMOS. What is AMOS? AMOS is a software given by IBM. Earlier it was a plugin in the SPSS itself, but after some time it became an independent software. So now AMOS comes separately from the SPSS. Sir, you have any question or just like that you are raising your hand? Okay. So before going to the software, we must understand some requisites. Variables are of two types, observed or latent. Observed variables are those variables which are directly measured, and all observed variables are known as observed items or statement, and we write them in the rectangle. Always we write observed variable in rectangle. So if in any model, if you find rectangle, it means the value of that variable has directly been measured. Second one is latent variable. They are measured indirectly, or they are represented by oval shape, and these are also known as latent, factor, and construct. If you can remember what we did in our EFA, exploratory factor analysis, from some observed statements, we create some unobserved factors. After completion of EFA, you must be aware that from the observed variables, we made some unobserved factors, construct, or latent variables. Let's say in factor 1, there were 5 statements. So on the basis of 5 observed statements, we create one factor, and on the basis of the nature of the statements, we have given the name of factor 1. So that factor was not directly measured. That was represented by a oval shape, and in SPSS it will be represented by oval shape, and it will be measured indirectly with the help of statements or items or observed variables. Sorry.
So can we say that latent variables are the independent variables or the sub factors of independent variable?
Okay, your question was the, the latent variables are dependent variable. Is it true or not? Was it your question or something else?
No, as you said that the some variables were unobserved. So are can we say that latent variables are the independent variables that we call in SPSS?
Independent from each other, independent from each other in on the basis of scores calculated in EFA. What if we are not
Okay.
going for EFA directly, we are going for CFA? You have determined already that this statement will go to this construct, this statement will go to this construct. Okay, then you have not checked either the score of the construct is uncorrelated or not. So if you
Hmm.
have checked the uncorrelatedness in EFA, then only you can say that my constructs are uncorrelated. Otherwise, this is not a precondition for construct that they must be uncorrelated. They must be
Hmm.
uncorrelated. So this is not the condition.
Yes.
Okay. So you got the observed statements, observed items, observed variables will be represented by rectangle, while unobserved will be represented by oval. Now, let's see. Variables are of two types. One is dependent variable and another one is independent variable. Dependent variable is also called as endogenous variable. Endogenous. And arrow always comes towards them. means arrow will come towards dependent variable. And independent variables are known as exogenous. Arrow always will go out of them. Are you getting my point? Or not clear? Is it clear or not? Dependent variable and
Yes, sir,
independent.
clear.
Yes, sir, clear. So arrow will go from independent variable to dependent variable, and independent variable is known as exogenous and dependent variable is known as endogenous. Okay, sometimes we read the papers and we find these jargons like endogenous variable, exogenous variable. So we got confused. That's why I made it clear. Dependent variables are called endogenous. Independent variables are known as exogenous. Now, question arises: can the latent variable be dependent and independent both? Yes. Guess. Can the latent means unobserved variable, the construct, the factor, can it be dependent as well as independent? Any idea?
Yes, sir, we can say that.
Yes. So please see here. What are you able to see here? So in this case, both are observed variables. Any of the uh, directly observed in item or latent variable can be dependent or independent. But in first case, what are you seeing? Both variables are my observed variables, directly observed variables, and they are items or variables. In this case, if I have two variables, directly I can go for regression. I can run regression. This will be bivariate regression. Any doubt here? In the second case, if I see my one variable is observed variable and another variable is my observed variable, directly measured. My unobserved variable is dependent while my observed variable is independent. Arrow will come from independent to dependent. In the next case, it has been reversed. My independent variable is unobserved, while dependent variable is observed. In the fourth case, my both dependent as well as independent variable are unobserved. Any doubt till now? Any doubt? No? Okay. Next. So in this case, let's say sales and advertisement expenditure, they are directly observed variables, and I can run simple regression because this is bivariate analysis. If I have more than two variables, I can run multiple variables. Now come to this case. Any of the dependent, independent variables, let's say motivation versus wages. Means wages affect motivation. So in case of motivation, what I need to see, this is unobserved variable. In case of unobserved variable, so I need to check for reliability and validity of this particular construct. It does not mean regression. Checking of reliability and validity does not mean the regression. So I will check the reliability and validity of my unobserved variable. Is it fine? If I find that the reliability and validity of my construct is good enough, then I will go for relation, that is correlation, or that is regression. I will go. If reliability and validity is not good enough, I cannot go for the next step. So In case of checking of reliability and validity of the construct, it is called CFA. So are you able to find out the meaning of CFA and EFA, difference between CFA and EFA? So checking the reliability and validity of construct means confirmatory factor analysis. Or making different factors is known as exploratory factor analysis. So it is CFA, and if I run the regression taking wages as independent variable, motivation as dependent variable, then it will become SEM. So what is SEM? Structure equation modeling, and SEM means CFA plus regression. CFA plus regression. And this regression is also known as path analysis. This regression is also known as path analysis. Are you with me? Are you with me?
Yes, sir.
Sir, we can
Okay.
run CFA separately and regression separately also.
Where? Where?
Like EMOS is providing us the facility of clubbing it together and running it together.
Yes, yes. We can run. We can run together. So
And
CFA.
without
Yes.
EMOS, CFA is not possible.
Without AMOS, CFA is not. You can check the reliability of construct we have done in our case. The reliability we have checked with the help of Cronback alpha.
Yes,
So that is the reliability. Construct-wise reliability we have checked now.
yes, we can check it through Cronback alpha also.
Yeah. But in case if you are taking the scale of scale developed by somebody else, then you need to check for the construct reliability. Okay. If you have run your own means EFA, then it will give you the factors that are uncorrelated and they must be reliable if your scale is reliable. Okay. Overall scale is reliable, then factors should be reliable. So in case of scale adopted developed by somebody else, you need to check it for CFA whether you are getting the same responses from the respondent what is expected or not. Sometimes you need to modify the scale adopted by you. Suppose there is a problem in one statement and respondents are not understanding the meaning of that statement. That's why you are not getting the results for particular statement. You can drop it. Or if you think that I should add some more statements according to the circumstances, you can also add. This is known as modification, modified scale. So in case of adopted, in case of modified scale, you must check for CA.
Okay.
Clear? And checking CFA plus running regression is known as
SEM.
SEM. So are you clear about SEM?
Yes. Structural equation modeling.
Done? Any problem? Okay. Let's move ahead. So, so in case if I'm running this model, productivity depends on motivation. This is also same. In this case, my motivation independent variable is unobserved, while my dependent variable is observed variable. Okay. Okay. Let's move ahead. In this case also it is the same. So if you have both dependent as well as independent variable as unobserved variable, then also it is the same. Yes, while running the analysis in AMOS, you must be careful. For what purpose? Here, unobserved variables or observed variables, whatever it is. But your dependent variable must have an error term. Can anybody tell me why this error term? Can anybody tell me why this error term on dependent variable? In Smart PLS, it itself take the error term, but in case of AMOS, we have to create this error term in the model. Can anybody tell me the concept of this error term? Anybody? No? Are you interested to know why we put this error term?
Yes, sir.
Okay, let's see. In case, if I write an equation of regression, what I write? What I write? Y is equal to alpha means A plus beta X. Is this my equation? Am I right or wrong? What does it mean? The X with intercept with constant is explaining the variance in Y, and this X is explaining the complete variance in Y. Yes or no? This X independent variable along with constant is explaining the variance in my dependent variable Y, but this X along with constant is able to explain the complete variance in Y. It means my YC must be equal to Y. It means YC is my predicted variable, predicted value of Y. My predicted value of Y and Y must be equal. Is it true? Is it true? Let's take some example. If I say advertisement expenditure affects the sales, and I run regression analysis, there will be some constant, there will be some beta, and on the basis of beta and constant, can I say the expenditure, only expenditure, advertisement expenditure along with constant affect my sales? Can I predict like that? Hello, are you getting my point or not? If I say that my advertisement expenditure explains my sales, I'm predicting like that. So is the only advertisement expenditure which affects the sales, or some other variables may be there?
There could be some other variables.
Some other variables. So they are unobserved variables. Unobserved variables means I have not
Yes.
included in my study. That is known as residual. That is known as residual. So the equation must be like that plus error. Error means the variables which I have not taken in my study, the variance explained by those is known as error. So that's why I will put error on the dependent variable, because the variance explained by this independent variable is there, but some variance will be explained by the variables which I have not included in my study. That variance will go to my error term. So that's why I need to put error on my, dependent variable. So either my dependent variable is observed or unobserved, I need to put this error term on the dependent variable. Is it clear or not? Hello, it's clear?
Yes, sir. Yes, sir. Yes.
Now, none of the oval comes without this rectangle. It means any unobserved variable cannot be drawn without the observed variables in a mouse. In a mouse, if I want to draw unobserved variable, I must draw the observed items for that unobserved variable. So no circle will come without rectangle. No circle. Okay. Now come to the error term. Error term and any one statement must have regression weight 1 to avoid unidentification problem. So in case of Amos, we have unidentification problem. So we have to put regression weight 1 to every error term or at least one statement of a construct that I will tell you at the time of running this model. Now, what are the assumptions of Amos? Let's see. It works on linear relation only. Non-linear relations cannot be determined in Amos. It works on metric data only. Metric means either ratio or interval scale data. On categorical data, it does not work. It assumes normality of data. We need not to check. It automatically check it and it assumes for normality of data. There is a requirement of more than one statement in a construct. You cannot take one statement construct, means like satisfaction, and you have only one statement for satisfaction. In smart TLS you can run, but in Amos you cannot run. Sample adequacy to be determined by KMO. With the help of EFA, we can determine whether my sampling adequacy is enough or not. If my sampling adequacy is enough, then you can go for the Amos. Okay. File to be used in Amos. Amos works on .sav file, which is SPSS file again. So it will not take your Excel file or any other format file. It will take only .sav. .sav means the file of SPSS. So in our case, if I see banking during the lockdown, this is .sav file. This is .sav file. So nature of the file must be .sav. And what is next? So we will see the file for any missing value. If there is any missing value, then Amos will not work. So we have to clean the data before going for Amos. We have to see the file. File does not have any kind of missing value. The first step is to attach the file. We will attach the file. It gives the statistical as well as graphical presentation. So let's see. We will go to the interface of Amos. Then I'm opening Amos. By the time if you have any kind of problem, you can ask me. Has anybody worked on Amos earlier? Anybody? Madam Sanmitra, you have worked? Okay. So is this visible to you? Amos file?
Yes.
Okay. So these are my tools. I will use them. And this is my canvas. Canvas, I will draw the diagram here. So let's understand what are the things available here. So this is rectangle. I can draw rectangle here with the help of this. This is oval. I can create oval. Okay. This is the erase object. I want to delete any item. I will delete. Okay. So now, if I have, this draw latent variable. If I draw latent variable, okay, I will add the statements. You see what is happening here. What is happening here? Can you tell me? This oval shape is unobserved, while the rectangles are observed. And every dependent variable has an errata. This is the errata. So if I want to make similar kind of diagram for more than one factor, I have the option to copy and paste. So what will I do? Copy and paste. This is the option for duplicate objective. So if you see duplicate objective, if I take this, so only one has been drawn because I have selected only one. What I need to do, I will select duplicate and I will select the preserve symmetry. Preserve symmetry means this will preserve the symmetry, whatever is there, this will copy the complete set of data. So I can copy many times, I can paste it. Okay. So what happened here? I have diagram on the canvas and outside the canvas. Is it fine or is this going to create any problem? Yes, anybody? No. Okay. So if I draw the diagram outside the canvas, it will create the problem. If I copy it and paste to my, okay, I'm copying it and I will paste it. It is telling me that this is outside. So let's see, will it work or not? I will copy here. So you can see the diagram on the canvas is directly visible, while the diagram outside the canvas is not clearly visible. So I should work on the canvas itself. What if I have done this outside the canvas? I have one option. This will bring all the diagram on my canvas. This is the option of resize the path diagram. And if I want to move them away, so I have the option of moving this truck option. I will select this with the symmetry, preserve symmetry. So this will move like that. What if I do not select the preserve symmetry? It will move only this way. This will create the problem to me. So I have the option of redo. This arrow is for showing the dependency, for running regression. This is the independent variable and this is dependent variable. While this two-sided arrow shows the covariances, correlation, okay, among them. So I have to remove the earlier arrows, then it will work. Okay. So this will show the covariances, or you can say correlation, and I can put like that. Okay, this with this, and this will this. So two-sided arrow always goes in curve, while single-sided arrow goes in straight line. If I want to put error term on any variable, I can put this error term. The number of times I click, it will rotate it where I want to see it. If I want to see it separately, I will see here. I can put on this. I can put on this. Okay. One more thing, I have option for rotation. So rotation, preserve symmetry. I can rotate this particular construct. Okay. With this, I can. I have created duplicate. I need to move it, taking the truck option. So I can move this way, this way, this way. And I can also, rotate them. Okay. So these are the options. This is for change the shape. If I want to change the shape of this, I can choose the shape. If this is for rotation, and okay, this is for selection. If I want to select one item, I will select one item. So after selection, it will become blue. And after selection, if I want to, make duplicate, I can make duplicate. Whatever I want to do, I can. So deselect all. If I want to select all in a single go, I will click this select all objects. So complete model has been selected, and preserve symmetry. And if I want to move, this will be moved. Okay, complete. It will be moved. So the first step is to attach the file. So I have explained you these things. Yes, please.
So can we reduce the number of squares?
Yes,
How will
definitely.
how
You
will we
can
do
reduce.
it?
You select the option of this erase object, cross, and you click on this. Okay, whatever you want.
Okay.
But at the time of reducing or deleting them, please remember, do not delete the item which has factor loading. Oh, sorry, the value 1. This value 1, which I have explained in PPT, is the no, okay. Have you seen this error term, and any one statement must have regression weight 1. So at the time of deleting, do not delete the item which has regression weight 1. So every error term, this error term has regression weight 1, this has 1. So in at least one item must have regression weight 1. So in this case, this has 1. In this case, this has 1. In this case, this has 1. If you delete this item, then your model will not work. Clear? Any doubt? And if you want to, okay, I have selected all. So deselect all. If you want to move this regression weight, you can move with the help of this. The regression weight will be moved. Okay. So if you want to move it downward, upward, if it is not visible, you can see. So if it is not visible, you can move to any place. Okay. This is the option. So I have told you these things. Now I will go to the next new file. No, I don't want to save. First of all, I will attach my file. So I will attach my file. This is the option select data file. This is the option select data file. So I will select the data file. What was my data file? So I will click on file name. This will take to my window and I will select my data file banking during lockdown. Banking during lockdown. So I can see I have selected banking during lockdown. 360 is the number of responses, and out of 360, all 360 are valid. None is missing. So this is the my data file. Okay. Now, how will I come to know whether my data file has been attached or not? I will go to list variable view. I will click here, and I will see all the variables are available here. Are you able to see? All the variables are available here. You can expand this. All the variables are available here. Okay, so I have attached my file. This will show me the variables which I have used in model. It is not necessary that all the variables available in my file are used in my model. So from here, we will take it forward tomorrow. We will run a model and I will try to run the model in Smart PLS also tomorrow. So I will try to run model in Amos as well as Smart PLS because day after tomorrow I will go to eViews. So my efforts will be to run model in Smart PLS as well as this, Amos tomorrow. So be on time. That's all from my side for today. Saurabh sir, over to you.
Thank you, sir. Thank you. I think
Thank you, sir.
Any question? You are most welcome. If you have any question.
so. The meeting is over. You can put your questions in the WhatsApp group also
Yeah, definitely.
or by email.
Definitely you can.
So the meeting is over. Please, all of you can log out.
Sir,
Okay.
if we can
Yes.
get this software,
Yes,
sir.
Sorry.